Today on How It's Made. Ball bearings, electrical wires, lost wax casting, and automated machines. With all the high-tech hoopla these days, the lowly ball bearing gets forgotten. But many machine parts need ball bearings to rotate. They're in household appliances, industrial machines, and car engine parts, such as alternators and fans. This is what's called a deep groove radial ball bearing. It has steel balls that move inside tracks called raceways. The raceways are carved into a set of heavy-duty steel rings. The balls are made of the same type of steel. They first prepare to shape the rings to the right thickness. They insert the inner ring into the outer ring. The set then passes through a grinder that alters the width to the correct thickness. A gauge checks the width of each ring as it exits. Now they separate the inner and outer rings in order to grind their outer circumference on separate machines. The outer ring enters the grinder, which shapes its outer surface to a precise roundness and diameter. A water-based liquid keeps the ring from overheating, which would cause warping. The ring exits the grinder through a gauge that checks the diameter. Next, the outer ring's raceway goes for grinding. Abrasive stone wheels with an oil coolant shape the surface to precisely the correct roundness and size. The inner ring and raceway go through a similar machine. Now the rings go for polishing. An abrasive stone lubricated with oil polishes the steel surface until you can see a reflection. Here's the before and after. Next stop, washing. They coat the rings with thick oil and a fine stone grit. They clean the raceways with kerosene. Elsewhere in the plant, they classify the steel balls according to size. These balls started out as steel wire. A machine cut them into pieces and a die punched them into rough balls. Those rough balls go into a grinder, which removes the bumps. Then other machines round them out and give them a mirror finish. This entire process takes a few days. The balls go through a furnace to harden. Then they get a bath in cleaning solvent. After several quality checks, the finished balls go into hoppers. The hoppers load onto the automatic assembly machine. The ball feeder sends the balls through tubes to a ball pusher that feeds the correct quantity of balls into the raceways of the now reassembled inner and outer rings. A ball divider positions the balls evenly around the raceways. Next comes the ball cage, a metal cage that retains the balls in position around the raceways. The first machine installs half of the cage, the half with rivet holes. The next machine carefully positions the outer half of the cage, the half with rivets. The machine test spins the bearing, then rivets the two halves of the ball cage together. The bearing is now fully assembled. Now it goes into a solvent bath, then to a series of automated quality control tests. This noise vibration tester makes sure the ball bearing operates quietly. Some types of bearings are lubricated with grease. A machine squirts grease evenly into the bearing's raceways, then inserts a rubber seal to contain the grease. A final quality control test. An automated scale tosses out any bum bearings that aren't the required weight. The good ones move on to the laser, which marks them with information such as the part number and the trademark.